looking at the 2012 practice test. Let's look at some of the multiple choice questions. Y equals x sine x, find the derivative. We've got x times sine x, so let's do our product rule. The derivative of the first part is 1, the derivative of sine is cosine. Do our little 2/3 bow tie. X times cosine x plus 1 times sine x. Which one is that? Looks like that's B. All right, let's look at number 2. Let f be the function given by f of x equals 300x minus x cubed. Where is it increasing? All right, so where is it not increasing? Where is it decreasing? What we're looking for is the derivative, and the easiest thing to do is set our derivative equal to 0, our derivative, just a power rule. If we set our derivative equal to 0, that's going to tell us where it's not increasing or decreasing, and then we can use our first derivative test. So if we factor out a 3, we're going to get 100 minus x squared, so x equals plus or minus 10. Let's look at our first derivative test. Negative 10, 10. Let's put them in. If I put in a number bigger than negative 10, like say negative 20, I'm going to get a negative number in here, which is going to give me a negative. If I put in something here like 0, 100 minus a smaller number is a positive number. And then similar to the negative 10 conversation, we've got negative over here. So we are increasing from negative 10 to 10. All right, number 3 says the antiderivative of secant tangent. So we need to know what derivative gave us secant tangent. I would definitely say we need to know the derivatives of sine, cosine, tangent, cosecant, secant, and cotangent. So let's run through them. Derivative of sine is cosine, derivative of cosine is negative sine, derivative of tangent is secant squared, derivative of cosecant is negative cosecant cotangent, derivative of secant is secant tangent, and derivative of cotangent is negative cosecant squared. Got to have those memorized, those 6 for sure. So secant tangent shows up right here. Its antiderivative should be secant plus c. We'll look at it number 4. If f of x equals 7x minus 3, then plus the natural log of x, then f prime of 1. So it's basically find the derivative, put in 1. The derivative of 7x is 7. The derivative of negative 3 is 0. And the derivative of natural log of x is 1 over x. So the derivative at 1 is 7 plus 1 over 1, which should be 8. All right. The graph of the function is shown above. Which of the following statements is false? I'm going to kind of run them back and forth here. The limit as x goes to 2 exists. Sure. We've got a left side limit and a right side limit. I'd say that's true. The limit as x goes to 3 exists. Yep, left and right. Now don't confuse that with differentiable. The limit exists, but it's definitely not differentiable at that point. And the limit as x goes to 4 exists. The limit from the left is 2, the limit from the right is 4. There's our false one. And let's just double check the last ones. The limit at 5 totally exists, and it's continuous at 3. Yep, it's continuous, just again, not differentiable. So answer there was C. Looking at 6, a particle moves along the x-axis. The velocity of the particle at time t is 6t minus t squared. What is the total distance? Not distance from start, but total distance traveled from 0 to 3. Let's take a look at what that graph looks like. It's going to have zeros at 0 and 6. And it's an upside down parabola. So the nice thing about that, if I want to go from time 0 to 3, is I'm not going to need an absolute value. It's just going to be the integral from 0 to 3 of 6t minus t squared, which should be 3t squared minus t cubed over 3 from 0 to 3. And if I put the 3 in, I get 27 minus 9. And if I put the 0 in, I get 0. So it looks like I should have 18. If y equals that, then y prime equals. We got a little power rule and chain rule going on here. Power rule says 5 times x cubed minus cosine x to the 4th times the derivative of the inside, 3x squared plus sine x. That's probably only going to show up right there. 7e. All right. Hopefully I got enough room here. I'm going to shrink this one down just a little bit. A tank contains 50 liters of oil at a time t equals 4. Oil is being pumped in at a rate where R of t is measured in liters per hour. Selected values are given. Use a right Riemann sum. When you see Riemann sum, you've got to think graph. So let's go ahead and graph that guy. At 4, it is 6.5. At 7, it is 6.2. At 12, it is 5.9. And at 15, it is 5.6. Obviously not to scale. Use a right Riemann sum. So let's take a look at what that looked like. Here's the right side. And I'd say if I'm going to do a right Riemann sum, I'm actually probably going to like read from the right. So I want these guys. So 5.6 times the base of 3 plus 5.9 times the base of 5 plus 6.2 times the base of 3. Now, no calculator, so I'm going to kind of approximate first and see what I get. Let's see if I can get there without actually doing it. 3 times, let's say 5 is 15. Let's call that 17.5. Now, I'm approximating. I'm going to call that 30. 3 times 6 is 18. I've got to be pretty close here. 48, 65-ish. I've kind of got two numbers there at 65. But what did I circle here in the beginning? Plus 50, because I've already got 50 in there. So I'm at 115. Oh yeah, I'm definitely right in between one of those two. So let's look. Was I above or below? This one was, well, this one's actually only going to be 17 point. That was a little above. This one should be 29.5, and this one should be 18.6. So now let's take a look. 8 plus 5 plus 6 is 9. Yep, there it is. I got the 10th place to be 9. That's the only one that has the 9. Totally, I mean, appropriate no calculator problem. Just would have to spend a little time doing the math. Looking at number 9. Zoom it in there. Good. For what value it is it continuous at 2? To be continuous at 2, well, first off, it can't be 2 here because of that guy. But now that I cross the 2 out, that's going to graph me y equals 2x plus 1 with a hole at 2. That's a pre-calc concept. So for a graph to be continuous, I have to be able to draw without lifting my pencil. But at that hole, I'd have to lift my pencil. So one thing we can do from pre-calc is we can fill that hole. What if I put a value there? That value would have to be 5. If I just put the 2 into the value, 2 comma 5 was my hole. So if the next value is equal to 5 at that point, I fill the hole and I make it continuous. Looking at number 10. What is the area of the region in the first quadrant bound by the graph of y equals e to the x over 2 and the line x equals 2? Area of the region in the first quadrant bounded by to 2. We love areas. 0 to 2, e to the x over 2. Now I'm going to show the u substitution here. If u is x over 2, or 1/2 x, then let's use that. du is 1/2. If I need a 1/2 here, I need a 2 here. So I've got to put a 2 there. I'm also going to change my bounds. To me, that's the right way to go, just a little easier so I don't have to do it later. Either way is fine. So if u is 1/2 x and x is 0, u is 0. If x is 2, u is 1. I just put the numbers right in for x. So my 2 times the integral from 0 to 1 of e to the u. Antiderivative of e to the u is e to the u from 0 to 1. Put the numbers in. E to the 1 minus e to the 0. That's got to be 2e minus 2. There it is. All right, click on to the next video.